Unit 14, we're going to start talking about quadrilaterals, and we are going to start with kites and trapezoids. A kite has exactly two distinct pairs of congruent sides. Okay, and what that means is that here in this picture, AB and AD are congruent, BC and DC are congruent, but between AB and BC, those are not congruent, okay? You can kind of think of a kite as, if we were to draw this diagonal, two isosceles triangles stuck together at the base, okay? In a kite, there are two different kinds of angles, all right? The vertex angles are the angles that are between the congruent sides, okay? So here, a different color, angle A and angle C are the vertex angles. All right, and then the non-vertex angles are B and D. Okay, they're between the sides that are not congruent. Okay, so that's the definition and some special parts of the kite. Okay, now we're going to start talking about the properties. The non-vertex angles of a kite are congruent. Okay, so we've got that same picture from above. Angle B is congruent to angle D. Those are our non-vertex angles. All right, and remember, congruent means that they have the same measure. The diagonals of a kite are perpendicular. So if we draw in our diagonals here, and remember those are the line segments that connect to non-consecutive vertices. So AC to BD. Those are perpendicular, or they form a right angle. Okay. Now, the diagonal that is connecting the vertex angles. So if we draw AC in here, those are our vertex angles. So that diagonal is, let's get our, so the diagonal connecting the vertex angles is the perpendicular bisector of the other diagonal. Okay, so again, the blue diagonal here, AC, that connects my vertex angles, but now I put BD in here. Okay, we know that they are perpendicular already, but it is also bisected. So those two parts, we'll say in here is point E. Okay, BD is bisected. Okay, and when something is bisected, it is cut into two congruent. I will get you chocolate chip muffins in a moment. When something is bisected, it is split into two congruent parts. Okay. And last but not least, the vertex angles of a kite are bisected by the diagonal between them. Okay, so again, I'm going to draw that blue diagonal in there, just like I did in the picture, but because that's the diagonal connecting our two vertex angles. Okay. And angle A is bisected and angle C is bisected. Okay, which means angle BAC is congruent to angle DAC, and angle BCA is congruent to angle DCA. We're going to move on to trapezoids, and trapezoids are quadrilaterals that have exactly one pair of parallel sides, and those parallel sides are called the bases. Okay, here in this picture to the right, DC is a base, and it is parallel to AB, the other base. Okay. Now the sides that are not parallel, in this picture it's AD and BC. Those are called the legs. Okay, and for a regular trapezoid, there's no special relationship between the legs. Okay. One property of a trapezoid is that the consecutive angles between the bases, so they're on different bases, are supplementary. All right. So what that means, angle A and angle D, their sum is 180 degrees. And then same thing for angle B and angle C. Those are consecutive angles that are between the bases, but their sum is also 180 degrees. Okay, that's what it means to be supplementary. Now, when the legs are congruent, just like we have an isosceles triangle if two of the sides are congruent, we have an isosceles trapezoid if two of the sides are congruent. Okay, so when we still have our parallel sides, those are the bases, but these non-parallel sides are congruent. That's an isosceles trapezoid. Okay. So when AD is congruent to BC, and we've got that one pair of parallel sides. Okay, now an isosceles trapezoid is still a trapezoid, so its consecutive angles are still supplementary, but there are two additional properties that make isosceles triangles special. Okay, now the base angles, so the angles that are on the same base, are congruent. Okay, so again, oops, let's draw here. We've got my legs congruent and this trapezoid. Okay, angle A. Sorry about this. A and B are congruent, those base angles that are on the same base. Goodness gracious. All right, and then angle C and angle D are also congruent. Okay. And last but not least, the diagonals of an isosceles trapezoid are congruent as well. Okay, so if I draw these diagonals in, connecting B and D, those two segments are congruent. Okay, in class tomorrow, we will go over some examples using these properties, and then we'll have a practice page.